Hello, algebra students, and we are in another section of Chapter 7. We are actually combining two sections, Sections 7-2 and 4, because the properties are going to be very closely related. So we're talking about multiplying and dividing properties with the same base. And what I'd like for you to be able to do is to simplify expressions when multiplying and dividing expressions with exponents in them. So what I'd like for you to first consider is what if we had the expression 2 to the second times 2 to the third? Well, that's technically an expanded form, 2 times 2 times 2 times 2 times 2, which is 2 to the fifth. And you might be noticing something. 2 to the fifth, well, if you look at these exponents, you can actually add them up to get that value. Now, this only works if the base is the same. So this is actually a rule. The rule is when multiplying powers, add the exponents, and that's important, so I'm going to box that in. And what that looks like is this little kind of formula, for lack of a better term, right there. So let's just simplify a few of these, shall we? Okay, so here I have 12 to the fourth times 12 to the third. Okay, well that becomes 12 to the seventh. We're going to want to put that into our calculator, and when I take 12 to the seventh, I get a very large number. I get 35,831,808. So the 12's matched, and then I took the 4 plus 3, which was the 7. Let's do that again. So I have -5 to the -2nd times -5 to the 7th. Well, the -5 is staying the same. And then I take -2 plus 7, which is 5. So now I have -5 risen to the 5th, which is going to be -3,125. Let's keep going. We're still going to use the same concept even if it's a decimal. So I have 0.5 to the -3rd times 0.5 to the -8th. Well, that's 0.5 to the -11th. And when I plug that into my calculator, I get 2,048. And that makes sense because this -11 would make it a fraction, so it's a fraction and a fraction. But what if we have exponents? Well, variables. We're gonna do the same way. So this variable matches, so they have a common base. So now just add the exponents because this is x to the 4th times x to the 3rd, which becomes x to the 7th. Now, if you have a number in front of it, you're still multiplying. There's not actually any addition in these problems. It's a property and a little bit like a quote-unquote shortcut. So I'm still multiplying. I have 4 times 9, which is 36. And then I have z to the 5th and z to the -12th. Well, the z matches a common base, so I'm going to take 5 and -12, add them up. I get z to the -7. Now remember, I don't like to have negative exponents, so if I put this over 1 to make a fraction, this is actually going to equal 36 over z to the +7th. I'll circle these answers as well. All right, let's keep going. Here I have 2a times 9b to the 4th times -3a squared. This whole expression is multiplication. This is 2 times a times 9 times b to the 4th times -3 times a squared. So I'm going to first focus in on the numbers. So I have 2, 9, and -3. When I multiply all of those together, I get -54. Then look at your a terms. I have a, if there's no exponent, it's a 1. So I have a to the 1st and a to the 2nd, which becomes a to the 3rd. And then I have b to the 4th that I still need to put somewhere. It can't be combined with anything, so it's just b to the 4th like that. In example 7, we have -4c to the 3rd times 7d squared times -2c to the -2. Okay, look at your numbers first. I have -4 times 7 times -2. So that is going to get me positive 56. Negative 4 times 7 times negative 2. Now I want to see if there's anything else I combine. Well, C and C are common. So when I multiply them together, I add exponents. So positive 3 and negative 2 just gets me to C. And then I still have this d squared I haven't done anything with, so it's going to be tacked on there at the end. I have one more example. I have negative j squared times k to the negative 2 times negative 12j. Well, that negative j squared is actually negative 1 times j squared times k to the negative 2 times 12j. So if I'm looking at my coefficients, or the numbers in front first, I have negative 1 times 12, which is negative 12. Then I have j to the second and j, so I'm adding my exponents, and I have j to the third, and then I still have k to the negative 2. But recall, I don't want negative exponents, so this is going to become negative 12 j to the third over k squared for that final answer. So this is with all multiplication. What if we have division though? Let's look at what we've got going on here at the bottom, see if we can find a pattern. 2 over 2 totally cancels to 1. But what if I had 3 2's on top and 2 2's on the bottom? Well, if I cancel, then I'm left with 2. Or if I have 2 2's on top and 1 2 on the bottom, 1 cancels and I'm still left with 1 2 remaining. Or if it's backwards, these still cancel, but I have a 1 over 2. What's happening here is if we were to consider these as exponents, we're actually subtracting exponents. So flipping our note page over, it says, when dividing powers with the same base, subtract the exponents. So if I have something risen to a power and something else risen to a power, same base, like they're both x or they're both, I don't know, 10, something like that, then you subtract the exponents. So let's look at some examples like that. Here I have 2 to the 6th over 2 to the 2nd. Okay, the 2 and the 2 match. Because the 2 and the 2 match, I'm able to subtract exponents. This is going to give me 2 to the 4th because 6 minus 2 is 4. The 2 is still staying the same. But what is 2 to the 4th? That is 16. Okay, now I have x to the 4th over x to the 7th. A little trick is to ask yourself, where's the highest exponent? And that's where your value is going to go. So you can think 4 minus 7, which is negative 3. So then that would be 1 over x to the 3rd. Or you can think, okay, 7 minus 4 is 3. I know it needs to go on the bottom because that's where the larger exponent is. And you'll still get 1 over x cubed. What if you have 2 letters in the same problem? Well, line them up. Here I have m's, so I can only subtract the m's with the m's, and I can only subtract the n's with the n's. So I have 2 and 5. Well, 5 is the larger exponent, and 5 minus 2 is 3, so I know I'm going to have m to the 3rd on the bottom. And then for the n terms, I have 4 and 3. Well, 4 minus 3 is 1, so n to the 1, or you can just write n, because remember, if there is no exponent that we can see, it's a sneaky invisible 1. Let's keep going. What if you have a negative exponent? My suggestion is to go ahead and rewrite it so that it does not get you all confused. So I have a to the negative 3, b to the 7th, a to the 5th, b to the 2nd. I'm going to rewrite that as b to the 7th over a to the 3rd, a to the 5th, b to the 2nd. So now I can subtract my b's or multiply. Because these are both on the bottom, I'm actually multiplying them. So the a's are working together and the b's are working together. The b's are going to be 7 minus 2 or 5, so b to the 5th up top. And then a to the 3rd and a to the 5th. Because they're right beside each other, that means multiplication, and they're in the bottom of the fraction. So a to the 3rd times a to the 5th is a to the 8th because I'm adding the exponents. Looking in this next example, I have k's and I have j's. Make sure you're lining your letters up. So k to the 6th over k, well, there's an invisible 1 on that k. So 6 minus 1 is 5, so I have k to the 5th up top. And then for my j's, 5 is the larger exponent down here. So I want to have 5 minus 2, which is 3, or j to the 3rd in the bottom. Okay, I have just one final example for us, and I want to rewrite this so that I have all positive exponents. I have x to the 4th, y to the 5th, z to the 8th, over x to the 4th, y to the 1st, z. Okay, you're going to line up your letters once again. So I have x and x, y and y, and z and z. You're subtracting top to bottom, or just wherever the larger exponent is, and make sure you put that where the variable belongs, either top or bottom of the fraction. So x to the 4th over x to the 4th actually totally cancels, so that goes away. I have y to the 5th over y. Well, 5 minus 1 is 4, so I have y to the 4th up top. And then z to the 8th over z is going to be z to the 7th. So I actually don't have anything in my denominator other than a 1 if you want to write it like that, but you can also write it just y to the 4th, z to the 7th as well. All right, that is everything for multiplication and division properties with powers for today. I will see you later in class.